In order to define a physical quantity, they are classified in two categories. The first one is scalar and the second one is vectors. Now, the scalar quantities are those quantities which can be defined with the help of their magnitude. This means scalars have only magnitude and vectors have magnitude, direction, and always always vector algebra. Now this is the mind map. So let's see physical quantities. They are classified in two types. The first one is scalar and the second one is vectors. Okay. Now let's see the examples of scalar quantity. First of all, time. Time is a scalar quantity because it is independent of any direction. If say in y direction 2 seconds means 2 seconds in every direction. This means time is independent of direction, hence we can say that time is a scalar quantity. Okay. Now let's say what is vectors. We needed magnitude and direction, magnitude as well as direction to define a vector. So let's take an example as force. A force of 2 Newton in y direction does not mean that it is same everywhere. Okay, this means a force of 2 Newton is only in y direction. Let's say this is the x-axis and this is the y-axis. Okay, the force of 2 Newton in y direction means it is in this direction only. This is in this direction only. Okay, it is not in x direction, it is not in z direction or any other direction. Now let's see why vectors are important. Why do we need vectors? See, scalar quantities were able to describe many physical quantities, but we need vectors in solving problems of mechanics and geometry. In order to solve problems in mechanics and geometry, vectors are very important, as vector analysis is a very powerful tool. Okay, now let's see how we represent a vector. Representation of vector. We use bold faces in order to represent vectors. Okay. Now if I have to represent a vector, then this is the normal way. And if I have to represent a vector, then how I represent it? In bold. Okay. This is bold A. Now as you see, it is very hard to use this bold A in our regular practice. This is bold face. This is very hard to draw. So how we represent a vector? It is represented by a arrowhead. This means a vector. Okay. Both are the correct representation of vectors, but generally this arrowhead is used to represent a vector. Okay. Now if I have to represent a velocity vector, then generally it is represented by v. Velocity is represented as v vector. This is how we represent a vector. Now let's see how the magnitude of vector is represented. The absolute value of vector, any vector, let's say this vector, we have to find out the magnitude of v vector. It is represented as or the absolute value of vector v. Okay. Now let's see some properties of vector. Properties of vector. The first property is along with direction and magnitude. Okay. Sorry, in addition to magnitude and unit. This have magnitude and unit. A vector must also have, first of all, direction. Okay. It has a specified direction. Second, it obeys, it follows parallelogram law of vector addition. Addition of vectors is commutative. Okay. This means vector addition is commutative. Okay. What does this mean? It means, say, p vector plus q vector is equal to q vector plus p vector. Okay, vector addition follows the commutative property. Now the graphical representation of vector. How do we represent a vector in graph? Now it is represented with a line graphical representation. It is represented by a line with an arrow head. Okay, let's say this is any line. It is represented by this arrowhead. Okay, this is the arrowhead, and the length and this length L of the line, this represents the magnitude, and this is this arrowhead shows direction. So the length of the line which we draw represents the magnitude, and the direction is given by the arrowhead. Okay, the length of this vector let's say L1 is less than L, as we can see. So this means if this is say B vector and this is A vector, okay, then this definitely means magnitude of B vector is less than magnitude of A vector. And what can we say about the direction? It is in opposite direction. B is opposite to A. Okay, now let's do some example. How to represent a vector in a graph. Okay, let's say we have to represent a force of 50 Newton in east and say 30 Newton in south. Okay, now first of all let's draw these direction. This is north, this is east, west and south. Okay, 50 Newton in east. Let's first of all we have to take some scale. Okay, it's not in a graph. Just as we take the scale, we take 1 centimeter, say equal to 10 Newton. Okay, this means 1 centimeter on that graph will represent a 10 Newton of force. Now if I have to represent 50 Newton on this point in east direction, where is east? It is in this direction. I have to draw a 5 centimeter long line in order to represent this 50 Newton vector. Okay, this is in east direction and this is 5 centimeter, and 1 centimeter is equal to 10 Newton, then 5 centimeter is equal to 50 Newton, and it is in east direction. So this is the representation of 50 Newton in east. Now I have to represent 30 Newton in south. So south direction 3 centimeter line. 3 centimeter line in south direction. This means 30 Newton force in south direction. This vector represents 30 Newton force in south direction. Okay.